Hi, this is Fred. In this video, I will demonstrate how you can get counter values from the camera and graph them in Grafana and getting views like this, so you can visualize this. So this is a demonstration and inspiration setup, and to simplify you getting this up and running, and I will go through all the steps of setting up everything and also do configuration. So the setup I'm having here, I'm having one camera. I have three different counters. The AOA line counter, I have my own ACAP, the motion counter, and object counter. So the values here doesn't really mean anything because I've been resetting cameras. But getting a view like this where you're having all the total objects going left, the total objects going right, all the cars going left, all the cars going right, and all the humans going left, and all the humans going down. So let's jump into this to show you the setup of all of these things and how you can replicate this solution. Here's the camera that I'll be using to count vehicles and humans passing through this road, the street. And I'll be using three different counters just to show you the variations. You see, I have a lot of ACAPs installed. One of them is the Access Object Analytics, and currently this version is 1.6.26. If I open that one, where I've defined two tripwires for counting, and we can open this one, and I've set one line here, me counting vehicles going right. That's why I call it right. And enabling all of these human vehicles, and there's no threshold in this case, and reset counters at midnight. And the same thing for the other. Go back, and if we look at left, and it's in the same position. And after a while, there will be some symbols showing the number of counts, vehicles, and stuff like that. So this one you can visualize that or see that the blue has to pass this yellow line. The other counter is my object counter. Let's there we go, a little bit bigger. So the object counter predefines 4 events, left, right, up, and down. And where I've marked an area where the objects needs to pass. So I don't. If people are walking here, I don't want to be counting them. So it's only vehicles here, and you can see the visualization of the objects being detected. In this case, this is the tricky part: is that it may take a while for, just like in AOA, you may need to validate that the counters, the tripwire, will work in different lighting conditions. And the same thing here, that because sometimes the analytics will fail and you may need to adjust to that. And I would typically, on a production system, group all the counting, because I don't want if there's about 2,000 cars passing here every day, I may not want to have 2,000 entries in my database. I will probably group this into 30 minutes or 1 hour, meaning if I have 1 hour, I will only have 24 entries per day in that database. I'm not still getting all the counter values, but I'll leave it on for every single. And also here, reset counters at midnight. And I do make some here. You can actually see how the analytics works. These are all stationary, and this is a miss detection, but it's not going to be counted because it's not moving. I've adjusted the detection area, and also I've added a exclude area here. So even if there were people passing here, and I put that area of passing by, still wouldn't be caught. But you use these to filter out false detections and getting a bit better behavior. And I'm not interested in up and down. I'm only interested in left and right. And the third is, so that is based on object detection where it classifies. I have also an ACAP called direction counter, or I've changed the name to motion counter, which is using a motion-based analytics. Looks very similar to the object counter, but it's using a different analytics technology. This is just counting the motions. So I'm not getting what type of vehicle or person. So I'm just getting object, object, object. So this one will not be able to count individual object types. When to use what depends on. There may be situations where the classification will often fail, where a motion counter is a much more reliable. But you have to test those things. So those are the counters on the camera. So we're going to be setting up the counter, the MING, and it's assumed that you have a Linux machine and you have a terminal, so you can access that through command line, and that Git and Docker is installed. I think most Linux installations would include Git, but if Git is not, so you can test that if you just go Git, and you should get some help there. And same thing with Docker. So if these two are not installed, there are tons of information on internet how to install the Docker and Git on your machine. So clear this one, and so we go to my GitHub, and there is a repository called MING, Object Counter Graph. And once again, the MING, M stands for Mosquitto, I for InfluxDB, N for NodeRED, and G for Grafana. So this is a MING Object Counter Graph. And this is what the package looks like. So what you do here, you go here and you go HTTPS, and you can just copy that URL. And then we go back to here, and we can say git clone, and I can just right click because I copy paste that. So there we go. So there is now we have cloned it. So now we can go into that directory called MING Object Counter Graph. And we can see with ls, we can do ls -l. So you see these are all the files. So you may want to adjust some settings. So let's go over the Docker Compose file and see what's in there. So we do nano Docker Compose yum. So Docker Compose tells the Docker which container should be running and downloaded and everything. So here you have one, the NodeRED, and I've set a unique name so it doesn't collide with other container names. And getting the image, the latest, and environment. So this is the time zone. So if you're in a different time zone, you should go in here and type a different time zone. The name of this, you could just Google for time zone names if you want to know the time zone name for your time zone. And the default port for NodeRED is 1880. So this is the port going inwards inside the container. But I have a lot of NodeRED, and I've set a less common port to access the NodeRED 8060. You can change that to whatever port you want. I have some links so NodeRED can access some of the internal source resources inside the container, which is InfluxDB and MQTT with names, so I could use these names to access those resources within the container. Some volumes that I'm keeping all the NodeRED files and data on inside the local directory. Then we have MQTT. As you see here, it's a different name, but ending with Mosquitto, and there you have NodeRED. Restart always, which I have here, that if the machine restarts or it should restart itself. The image is the Eclipse Mosquitto. We can scroll down a little bit here now. Same thing here. Oh, sorry. Where am I? MQTT. There you are. The default port for MQTT is 1883, which is the port inside the container. But since I also have other Mosquitto brokers, not to get any collisions on there, I've used a different port. And you can change this if this is the only MQTT broker, change that to 1883. And this is just where the files of Mosquitto data is going to be stored in. Then we have InfluxDB with a container name and restart always. I decided to stay on 1.8.10. If you want to change that, go ahead if you want to go up a version. In this case, I do not expose the Influx database outside the container, so you cannot access the Influx database from the outside. If you do want to access the Influx database outside the container, you just remove these two. But this means that I'm not exposing the ports. And then we have Grafana, getting the latest always. The ports I'm using, I don't have any collision on 3000, so I'll leave with the default port. This is typically the user interface. And then this one links also to the InfluxDB, so you can access that with a nice name. Same thing here with the time zone. I'm going to be updating here, so I'm going to be updating, so you're not going to be seeing this. I do not want anonymous access, but I do want a different kind of setup when Grafana, depending on the interval, what I'm getting. This one is not, so you should not see these. I'm just removing that. I'm going to be updating these in the repository. And volumes, and then you have MQTT data on volumes. So I did make changes and Control-S, Control-X. And that's it. So the first time you start it, it should pull down all the containers. In this case, this is already done, so we can just, depending on how you set up your Docker, maybe you may need to do sudo docker compose up, and let's detach it so it'll be running in the background. And I need to set my sudo, and since it's already installed, they just starting all the containers. So this is the NodeRED, and it's the same the IP address to your server, and 8060 as that was the port that was set in the Docker Compose file. So I'm going to go over these one by one to show you what's going on. Let's get back to that. So just going into the Influx setup. So as you see here that there is an inject node initialized, and you see 1 there, meaning that this is going to be injected once after NodeRED starts. So it will automatically create a database called log And also, oh, it's not going to be quarter, it's going to be a policy week. So it creates a retention policy for 1 week, that meaning that data older than a week will automatically be removed. You can set a different name and set a different duration. So if we could use, if we want a 1 month retention, and then we can set either 4 weeks. There is not a month. So but in this case I only want to have the retention, so reducing the risks of filling up your storage with unnecessary data. A little bit more advanced, the Influx could also do downsampling. So like every day it will downsample all the counter values into one single retention policy that's forever. So you'll only have one entry for each day for each counter. Well, let's do cancel here. So that's going to do automatically. If you want to reset the measurements, and the measurement that we're using is counters, the name we just set that name. So these are, so this will clear the database of all that table. And here you can also view all of them. So it's been going on for a while here now, so we have a lot of data. So let's go over what's happening here on the data input. As you see here, I have 3 different counters, left and right. And this is not you would typically have. This is more for inspiration, and you need to go in here and alter depending on your setup. So let's go through. Let's take the this one, which is the I'm using SimQTT to get the data. If you're using the MQTT client, you need to change the topic that you're listening into. So let's enable this, and we can look at the data coming in. So here we did get one, and so I need to reformat this before I put it into the Influx node, and we can go in here. So I'm setting message payload. So this is an array of 2 objects. So these are the values and these are the tags. The tags are being used to group. You'll see that in Grafana. So it's the time, message timestamp, and I'm changing the property names so I can have equal property names and better, that I would say more appropriate property names. So instead of total human, I will call it human. Total car, I'll just call it car. Total truck, truck. And in this version of AOA, there is a bad property name, which is not liked by JavaScript. So I need to extract that. And the direction, in this case, I know that this scenario 2 is the right. And then I'm giving it a counter name so I can group on AOA. I just call it AOA. And then the device, which is the serial number, because I may have many counters and I want to group them on device or filter on a specific device, so I know which device was actually producing the counter. And so if you were looking into, let's clear this one, and if I'm using my object counter, and let's go deploy. Let's see if we get a value. Anyway, before we do, we can go in here, and the object counter has a slightly different payload, but the payload that I'm injecting into Influx needs to be similar to all counters. So you get, but the same structure, value, human, car, truck. In this case, it's direction right, and I call this one just object counter, and I have the device payload for the tagging. And if you go in here, you would see, yes, left. So it's basically the same, but it's just having a different direction. And then it just injects into, here we see an object counter coming in. And the same thing with the motion counter. So we can go in here into Influx setup, and we can say just view all, which gives you an array, and you can go into any of these And you can say here you see the data structures that was being logged in the database. So this was the object counter going left, totally human. And so change this depending on your setup. So let's launch Grafana. So go to the IP address where your server is, and you do :3000. That's the default port for Grafana. You will be coming to this page, and the default password for Grafana is admin, and the password is admin. And you log in, and you're going to be requested to change the password. So I'll just change the password. And sorry, yeah, like that, and submit, and don't save. No. So here is now Grafana. The first thing that we have to do is setting up a data source. So you go into this cog and you go to data sources, add data source, and InfluxDB. You can change the name. This is just a nice name, query language. The URL, as we did a link in the Docker container, we have a reference called InfluxDB, so we can use that HTTP in InfluxDB and :8086, which is the default port for Influx. Scroll down. There is no authentication on the Influx currently in this demonstration. There we don't. Oh, sorry. Why is that? And the database that we created is called log. And that's what you saw in the NodeRED. And test it, and data source is working, and one measurement found. Save and test. And now we can go back. So now we can add some dashboards. So let's say you go in here and you add a new dashboard and a new panel. And you see here, this is the data source. And the retention policy that we use here is week. So you have to select week, and then we have to select the counters. So now you should be able to see if you had some data in the database. So don't care about the data that is being displayed here, because some of these counters are being up and down and testing. So we'll go through these. So we're going through counters, and we do want to filter, in this case, on a specific device. I have 2 devices, but I will go for this one, which is that camera looking at the road. And this is going to be the panel that shows objects going left. So here's the nice name for this panel. And I also want to filter on the direction here and select the value left. The value here is the total counter value. And I don't want the mean value. I want, you go aggregations and go distinct. Still looks a little weird, but we will group this into counters. So you can see here that I'm getting counter AOA, motion counter, and object counter. I want to get more friendly name here, so we can put in alias, and in Grafana you go $tag, and in this case I want to use the $tag counter. So now you see here the names are much better. And so here you can decide how you want your graph to be. That it's going to be, let's see, the legend list. time zone default, placement, show grids, text. So this is going to be a line counter. You can change if you want to have, graphs with the bars and stuff like that. But there's one more thing that I want to change. It's where is that? Standard options, data link. So yeah, it's I want to show the legends or the as a table, and I want to show it to the right. And now I can go in here and choose additional that maybe I want to show the last value. And these are the counter values. So we are, and then depending on the time interval that you want to be grouping this one, we can do this in 1 minute interval, or we can do it in 5 minute or 10 minute or up to an hour or whatever, or you can go even higher than that. So, but we can also use it at distinct values like this. Now we can apply. So now we have one showing the total objects going left. So let's make a going right. So we can go in here and go to more and just duplicate this one. So now we have 2 left, and we can edit this. So this is going to be called right, and the direction here is going to be right. So now we see. So we can apply this. So now we have left and right of total values. So let's look at the number of cars. So I can, same thing here, I duplicate this and move it down here. So it's going to be left and edit this one. And let's make this left cars. And now I need to change the value. So I will select car. And it's going to be left and apply. So I now have left cars. Let's make a duplicate and change this to right cars. And the change here to right. So it's going to be cars, and it's going to be apply. So now I have cars. Just for sake, let's do humans also. I will go in here and go duplicate. I'll move this one down here, edit, there, and left humans. And it's going to be not car, it's going to be human. Apply. And right human. Clone. Duplicate there. Edit. And we are going to be right humans, and it's going to be right there. And you can do this for all the values that you see here that have their own counters. So that was going to be human. Apply. So you can just keep going and just copying this in here. So now you can go in here and just group that or select that I want to see the last hour. Or you can zoom out. So I have a bunch of data that I've been playing around with. It don't really mean anything because these counters are being reset and restarted while doing this demonstration. But you can go in here and says, okay, let's go in here and let's look at that. And you see here that the last total value here. And you can add more values if you want to in your table. And that's about it.